This Math 12 video lesson follows up on the previous one where we talked about linear regression. Now, we're going to explore how to use the calculator for quadratic and cubic regressions. This video is going to address the course expectation of being able to decide what kind of polynomial best fits a graph and to use technology to solve a problem involving a polynomial function. So we're going to practice finding quadratic and cubic regressions and practice choosing the curve of best fit. From our work at the start of the unit, we've seen that not all scatter plots show a linear pattern, so we're going to need to use other polynomials. For example, this first scatter plot looks cubic. The second scatter plot looks U-shaped, so it's probably quadratic. But then again, that could be one of the two vertices of a cubic function, so we need to discuss how we decide what kind of model to use. It turns out that higher degree regressions are almost always better models. For the purposes of our course, we're often going to be told what kind of regression to do. And in the example in this video, we'll talk about what to do when R² doesn't give you a hint. To start with, we enter our data into the TI the same way we did for a linear regression, choosing to edit our lists after pushing the Stat button. And just like a linear regression, list 1 represents your independent or X data, and list 2 represents your dependent or Y data. Just like with a linear regression, we push the Stat button and arrow over to the Calculate menu. But now we are going to look at more options. We already know that option 4 is a linear regression. Option 5 will perform a quadratic regression, and option 6 will perform a cubic regression. When deciding what kind of regression to do, we have to keep in mind that you can only do regression when you have one more data point than the degree of the regression you're trying to do. Since a linear regression has a degree of 1, we need 2 coordinate points in order to be able to do a linear regression. Since a quadratic equation is degree 2, we need 3 points to find its equation. And so we need 4 points in order to be able to run a cubic regression. As I've already mentioned, most questions will tell you what kind of regression to use. But sometimes, you have to decide what the best model will be. Let's take this data and check the correlation coefficients, or R², for entering this table into our calculator and trying all 3 regressions. Hit pause and find those 3 R² values now. When you're ready, continue the video. Something interesting happens with these regressions. We notice that for a quadratic regression, we get an R² of exactly 1. In other words, that quadratic equation is a perfect model. But we also get an R² of exactly 1 for a cubic. What's going on here? Well, take a look at the data your calculator gives you for that cubic regression. Your calculator tells you that the leading coefficient is 0. In other words, we have exactly 0 x cubes, which means this isn't actually a cubic function. It's a quadratic function. And so a quadratic equation is going to be our best model. Based on that quadratic equation, our perfect modeling equation is y equal to negative 5x² plus 0x's plus 20. And we can choose not to write down the 0x term if that makes you feel more comfortable. Now let's take a look at our prediction. If we're going to predict the position at 0.8 seconds, seconds was our x value, so we're going to replace the x with 0.8. Remember to follow the order of operations so that we take 0.8 and square it, then multiply by negative 5, and then add 20. Ultimately, we're going to find out that we predict the position to be 16.8 meters. This example also asks if this is interpolation or extrapolation. Well, 0.8 fits in among the x data that we're already given. Since it fits inside the data, this is an example of interpolation. That's the end of this particular video lesson. If you're ready, move on to the practice problems. If not, rewatch the video to listen to any explanations or copy down any extra notes that you need.